All right, the final video in section 3.3 will be looking at the proof of integration by parts. If you remember from the very first video on this, integration by parts is just the product rule of derivatives applied to integrals. So if I had a product like f times g prime, I would get a derivative which is f prime g of x plus f of x g prime of x. All right, and so we want to use that to prove that the integral of f of x g prime of x dx is f of x g of x minus the integral of f prime of x g of x dx. So that's the original statement of integration by parts. It's actually more formal and more precise than the integral of u dv and blah, blah, blah. It's the same spirit, but this is more precise because I see the variable x and I see what's going on. And so I will be proving this version here. All right, so let's start with the product rule. I have f of x, g of x prime is this. And so that means this function here is an antiderivative for all of this. So if I wanted to integrate this right here, the answer would be this plus c. All right, so the integral of f prime g of x plus f of x g prime of x is f of x g of x plus c. Right, remember when we take an integral, it's any antiderivative plus c. We have an antiderivative. All right, so we have all of the terms. So I'm going to split this because I want two different integrals for this. So I'm going to get f prime of x g of x dx plus the integral of f of x g prime of x dx. And then I want f prime g of x, so that one, I want it to be on the other side, so I'm going to subtract it. All right, notice that I got rid of the plus c. At this point here, I have integrals on one side, no integrals on that side. That's why I need the plus c. But here I have an integral here, and I have one here as well. So as long as I have integrals on both sides, I don't need a plus c anymore. All right, so that's it for integration by parts.